Good afternoon and welcome to the second episode of Ahargana. I am starting this episode on the shores of this Sharavati balancing reservoir. The main Sharavati reservoir is a little bit upstream. It's created by the Linganamaki Dam. This is a smaller reservoir called the balancing reservoir because there is actually a reservoir and dam system here in place which feeds a set of 3 hydel power plants. And these 3 power plants put together serve about 50% or close to 60% of the electricity needs of the Karnataka state. And almost 50% of the needs of Bangalore city are served from these Sharavati hydel power stations. And needless to say, the hydel power is completely environment friendly. There are no emissions here. And this is the way to go. And this is what nature does for us, including generation of electricity for our day-to-day lives. It's a beautiful day here. The sun is shining right on my head. It's close to noon, about half an hour to noon, but I said good afternoon because it feels like noon to me. And I can feel the breeze blowing. You cannot feel it. I can hear the birds chirping. I can hear a few cow bells. Maybe you can hear them too because my microphone picks up the sound. But I'm not here to talk about nature. At least from the first episode, you know, I'm not here to talk about nature on this scale. I'm here to talk about the Hindu calendar, which is about nature on a much grander scale. So what you see here is nature on a terrestrial scale, whereas the Hindu calendar is based on the movement of the sun and the moon around the earth in a geocentric model, and that is on a celestial scale, but it is nature all the same. So in the last episode, we went into details about the geocentric model of the system. In this episode, we will dive down deeper into the topic. Now, there are many calendric elements in the Hindu calendar. Instead of just throwing about all the calendric elements at random, our ancestors put together certain groupings of these calendric elements called Maanas. And according to the Surya Siddhanta, there are 9 Maanas of time. Each Mana is a collection of calendric elements. So to quote Surya Siddhanta, the 9 Maanas are Brahmam, Divyam, Tata Pitrayam Prajapatyam, Guros Tata Saurascha Savanam, Chandramana Nakshatram, Maanani Vai Nava. Now, out of these 9 Maanas of time, I'm going to focus only on the latter 4, which is Saurascha Savanam, Chandramana Nakshatram, Sauramana, Savanamana, Chandramana and Nakshatramana. Because these 4 Maanas are defined based on celestial movements, i.e. based on astronomy. The first 5, on the other hand, are completely defined in an arithmetic fashion. So the first 5 are Brahmam, Divyam, Tata Pitrayam, Prajapatyam, Guror. Now these 5 Maanas, I said, are defined in an arithmetic manner. So I will give you an example. If you start with one of the basic calendric elements is the Saura Varsha. That is a solar year. That is the time it takes for the sun to go around the earth one full orbit in a geocentric model with the earth at the center. Now, based upon that, there are a whole series of definitions which are created. For example, one solar year is actually one day of the gods, a Deva Dina. 360 Deva Dinas make a Deva Varsha. 12,000 Deva Varsha make a Mahayuga or Chatur Yuga, as it is more popularly known. 71 Mahayugas make a Manvantara. 14 Manvantras make one Kalpa. One Kalpa is the daytime of Brahma. The second Kalpa is the night time of Brahma. So 2 Kalpas make an Ahoratra of Brahma, a day-night pair of Brahma. 360 such Ahoratras make a Varsha of Brahma, a year of Brahma. And 100 such years makes up a lifetime, a lifespan of Brahma. Completely arithmetic in nature, starting from a definition of a solar year, which is astronomical in nature. And if you do the computations and the multiplications, I think a lifespan of Brahma works out about 3.11 trillion years. entirely constructed in arithmetic fashion. But since my focus is on astronomy, I will not go into the details of those. I am going to stick with the details of Saurascha Savanam, Chandrama, Nakshatram. Sauramana, Savanamana, Chandramana and Nakshatramana. Out of these 4 manas of time, I will start this web series by going into the details of Chandramana. Why Chandramana? Because Chandramana, many people are already familiar with Chandramana, and also in my opinion Chandramana is relatively easier to understand. Now there are 4 calendric elements in Chandramana. There is first of all the Paksha, which is a half phase or the half orbit of the moon, and there are 2 types of Pakshas, Krishna Paksha and Shukla Paksha. The 2 of them, Krishna Paksha and Shukla Paksha, put together form a Chandramana masa, Chandramasa, and 12 Chandramasas make up a Chandravasha. Now after these I will go into the details of one more Chandramana calendric element called Tithi. Tithi is a rather intriguing concept. I have already hinted at this in my earlier videos, and I will explain that in much greater detail. So let us start this episode with Paksha and Chandramasa. What is a Paksha? So you all know that from high school astronomy, which you have studied. Please try to recollect. You know that there is new moon, there is full moon. We refer to new moon as Amavasya and full moon is Purnima or Paurnami. The time taken by the moon to move from Amavasya to Paurnami is one Paksha, and that is called Shukla Paksha. During Shukla Paksha, the moon becomes brighter and brighter and brighter, and finally it is full, bright, lighting up the night sky. On a clear day, or rather on a clear full moon night, you will be even be able to read a book if you sit on the terrace of your house. It's that bright. The time taken by the moon to move from Purnima back to Amavasya is called Krishna Paksha. So during this time, the full moon starts becoming smaller and smaller, or rather it becoming darker and darker, and finally it completely disappears. It becomes a crescent and completely disappears. So this cycle, it happens like clockwork from Amavasya to Purnima and back to Amavasya. So one cycle from Amavasya back to Amavasya is known as a Chandramasa. Now there are 2 points I have to explain in greater detail here. So I said one cycle from Amavasya back to Amavasya. I did not say one orbit of the moon. When I show you the animation, this will become even more clear, because one orbit of the moon is completed, but remember your high school definition of new moon. It's not an absolute definition, it's the position of the moon with respect to the sun and the earth. If the moon comes in between them, conjunction, then you have a new moon. So when the moon completes one orbit, if the sun has moved a little bit more, the moon has to also move a little bit more to create the next new moon. So one Chandramasa is not one orbit of the moon, but it's a little bit more. One orbit of the moon is about 27.3 solar days, whereas one Chandramasa is about 29.5 solar days. The second point I would like to make here is, I said that from Amavasya to Amavasya is one masa. This is what the Surya Siddhanta defines. But this is a closed circle. I mean, it's not a circle, it's an ellipse, but it looks pretty much like a circle. So there is no starting point. Now we have taken an Amavasya starting point, why not a Purnima as the starting point? In fact, that is done by many people. There is one tradition called the Purnimanta tradition, which starts the masa with Purnima, and until the next Purnima, that time is one masa. The tradition which starts from Amavasya to next Amavasya is known as the Amanta tradition. By and large, south of the Vindhyas we follow the Amanta tradition. By and large, there are always communities which are exceptions, and by and large north of the Vindhyas follow the Purnimanta tradition. So this is all verbal explanations of the elements of calendric elements of Paksha and Masa. But I will now show you visually as to how this looks like by showing you an animation in Stellarium. And I can see behind me there is a cow grazing. You might have heard my neighbor's bells tinkling during my video. But now let's go into a celestial scale. I will show you in Stellarium Amavasya, Purnima, the two Pakshas, Krishna Paksha, Shukla Paksha, and a Chandramasa. Take a look. Okay, let's get started. We have already seen the geocentric model of the solar system, but I will still give you a quick overview here. This green circle that you see here is the ecliptic. That is the path the sun takes to go around the earth in a geocentric model over 365 solar days. The markings on this circle, 0 degrees, 90 degrees, 180 degrees, 270 degrees, these are shown just so you can locate the position of any heavenly body with respect to this ecliptic. So for example, we can see that Chandra and Surya are short of 30 degrees. They are closer to, this is 10 degrees, this is 20 degrees, so they are just maybe 21, 22 degrees is where they are positioned right now. Now you are able to see 7 of the 9 Navagrahas in this model. So here is Chandra, which is the moon. Here is Surya. This is Guru, Jupiter, the largest planet in the solar system. This is Shani, Saturn, more appropriately called Shanaishchara because he is a slow moving planet. This is the red planet Mangala, Mars, and here is Buddha, Mercury. And peeping here from behind the moon, you can see Shukra, which is Venus. So these are 7 Saptagraha out of the Navagraha. The 2 which are not shown here are Rahu and Ketu because they are not physical bodies. So Stellarium cannot show them visually to you. There is nothing to see there. They are just 2 points in space. Now, I have chosen April 12th, 2021, 8 o'clock in the morning as the starting point of this animation. The reason for that is the moment of Amavasya. Now, Amavasya is by definition when the sun and the moon are in conjunction, which means they are in the same ecliptic longitude. As I already showed you, it's somewhere close to 22 degrees ecliptic longitude. Both of them are positioned there. Now, if you are confused as to why the sun and the moon are so close to each other, I mean, how can they be so close? I mean, the sun is far, 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 far away, but here the visual is showing that they are practically one on top of the other. I will have to bring back to your mind, to your recollection, the fact that this is an observed model as it is observed from the surface of the earth. So I turned on the surface of the earth, and you can see that this is 8 o'clock in the morning. So the sun has risen from the east, that is east. The sun has come up this much. The moon has risen with the sun and moved this far. And when you are observing from the surface of the earth, you can see only half of the ecliptic at any given point in time because the other half will be below your feet. But since Stellarium is a software, it's possible for me to turn off the surface of the earth so you can see the entire ecliptic. So this is a quick recap of the geocentric model, and now we can proceed with the animation which illustrates Krishna Paksha, Shukla Paksha and Chandramasa. So I'm going to start the animation now, and I request you to please observe what happens on the screen. The animation is ticking, time is being simulated. So you can see the movement of the moon, and the moon is becoming brighter and brighter. And this period is known as Shukla Paksha. Good. Shukla Paksha ends with Purnima, and you can see the moon is full and bright. This is Paurnami, Purnima, or full moon. And this is a moment when the moon and the sun are in opposition to each other. And we started with April 12th. Our Purnima is on April 27th at 9 o'clock in the morning. And this entire period is known as Shukla Paksha. Now I'm going to restart the animation once again. Now Krishna Paksha has started, and the moon is becoming darker and darker. And the moon is approaching the next conjunction point, and there it is. So this is the end of Krishna Paksha, and Krishna Paksha ends with Amavasya. So we moved from one Amavasya through a Purnima to the next Amavasya. And the next Amavasya happened on May 12th, just after midnight, about 12:30 in the night. So this, in a sense, is one cycle of Shukla Paksha and Krishna Paksha. And this cycle, from one Amavasya to the next Amavasya, is one Chandramasa. And that means Purnima is right in the middle of Chandramasa. Now, there are two key points that I have to highlight here. The first point is that the moment of Amavasya belongs in Krishna Paksha. What does that mean? That means that, first of all, Amavasya is just a moment in time. It's not a long period of time. Though in this animation I am starting and stopping. So for example, right now on this screen it is showing Amavasya, but it seems to last eternally because nothing is moving. Now nothing is moving because in Stellarium I stopped it from moving, but in real life everything is moving all the time. The sun, the moon, the heavenly bodies, everything is in motion, including Earth is spinning on its own axis. So since everything is moving all the time, Amavasya, which is a point in time when the sun and the moon are in conjunction on the same ecliptic longitude, is just a moment, just one kshana, and then it's gone. But that moment of Amavasya is counted as part of Krishna Paksha. So I am essentially saying exactly what's on the screen here. Krishna Paksha ends with Amavasya, and immediately after that Shukla Paksha starts. Conversely, Purnima, the moment of Purnima, of full moon, that belongs in Shukla Paksha. In other words, Shukla Paksha ends with Purnima, which is also what I showed you in the animation earlier. These are subtle points, and when we get down to Tithi, the same terminology, Amavasya and Purnima, would be used as the names of Tithis. At that point in time, I will revisit this subtlety. Please keep in mind. The second point I would like to highlight is this plus symbol here. This yellow plus sign. What does that indicate? That is the point where this animation originally started, when I had positioned Stellarium at April 12th, when the previous Amavasya had happened. But now we are on May 12th, the next Amavasya has happened, but not at the same point, it has happened here. Remember, at that time I was pointing out that the sun and the moon were positioned around 22 degrees.
Now they are significantly past 30 and they are closer to 60 now. Maybe they have come to 50 degrees. So what is really going on here? This means that while we were watching the movement of the moon becoming brighter and brighter and darker, the sun was not standing still. The sun was also moved. So I would like you to once again observe. I will replay this animation, but this time observe this plus symbol, what's happening with the sun also in addition to the moon. I started the animation again, but this time you observe the movement of the sun. It's no longer in the starting point, which is indicated by the plus symbol, but the sun is also moving. And it's come to 30 degrees and it's moving slowly, much slower than the moon, but it's moving all the same. You can also see that Shukra is moving, Buddha is moving, Mangala not so much. So the sun is moving further and further away. I will now shift focus to the moon. The moon is approaching the starting point. This is where the last Amavasya happened. This is where the moon's orbit started and when we were tracking it, and now it has come back. There, it's come back, but the next Amavasya has to happen here. There it is. So what happened was the moon did one full orbit, but that is not a Chandramasa. For a Chandramasa, the moon has to move some more. It has to do one full orbit and then a little more. This is a subtle point. So a Chandramasa is not the same as one full orbit of the moon. It is larger than one full orbit of the moon. In actual numbers, an orbital period, the sidereal orbital period of the moon is 27.3 days. Whereas the synodic orbital period of the moon from one Amavasya to next Amavasya is 29.5 days. 27.3 plus a little bit more, 29.5. This distinction between Chandramasa and orbital period of the moon is a subtle point, but it is visually made clear to you by using this animation. One last but very important and interesting point I have to convey now. Look at this circle, the ecliptic. In fact, it's not actually a circle, it is an ellipse. But the eccentricity of this ellipse is so small, it's almost close to zero, that it for all practical purposes looks like a circle. Now, can you tell me what is the starting and ending point of a circle? Is this the starting point of a circle? Is this a starting point? Is there any way to tell what is the start? Where is the start of the circle? Now, of course, you can say that there is a 0 degrees here, so this must be the start of the circle. But that is only a convention, that the modern astronomic convention, that the position where the sun is on the vernal equinox, we will consider it as 0 degrees. In our case, we have taken a different approach, saying the position where the sun and moon are in conjunction, we will consider that as the end of one month and the start of the next month. Amavasya is the end of the previous month. The next month starts. And these are conventions we adopt because there is no natural start or end to any closed loop. So a closed loop in mathematics is like God, because in Tamil they say Adiyam Andamum Illa Jodiye. No beginning or no end to a closed loop. So if we are adopting this convention that Amavasya marks the end of a month and the start of the next month, why not go the other way and say that Purnima marks the end of a month and start of the next month? Is there something wrong with that? Is there any reason why we should not do that? No reason at all, because that is precisely what a majority of communities north of the Vindhyas do. They do say that Purnima marks the end of the month and a new month starts immediately after Purnima. and proceeds until the next Purnima. Now, this brings two conventions then. One tradition in which Amavasya marks the end of a month and the start of the next month. Another tradition where Purnima marks the end of a month and start of the next month. The former tradition, where Amavasya marks the end of the month, is called the Amanta tradition. That is nothing but Amavasya Anta, Amanta, ending with Amavasya. This tradition is followed by many communities south of the Vidyas, including the one I belong to in South Canara. On the other hand, the tradition where Purnima marks the end of a month and start of the next month is called Purnima Anta, ending with Purnima. So these two traditions coexist in India, and this does cause a little bit of, what shall I say, confusion or problem, because the Krishna Paksha of a month, the name of the month will differ depending upon which tradition you are using. The Purnimanta people will say it is 1 month. The Amanta people will say it is the previous month, because the Purnimanta has already switched over to the next month. But I will talk more about this in the next video, where I will actually go into the 12 months, the Chandramasas that make up a Chandravarsha. Until then, I will just point out there are two traditions, Amanta and Purnimanta traditions, when it comes to defining the end of a month and the start of the next month. So this brings me to the end of this video, this set of animations. And thank you very much for watching.
We are now back on the shores of the Sharavati balancing reservoir, except that I have moved away from the water line. I've moved into the tree line, so I am inside the Western Ghats. The breeze is still blowing. I'm not hearing too much of birds chirping, but I can hear a small brook running by. I don't know if I should suppress that sound in post-processing or let you hear it. In the Stellarium animation, you saw all about the movement of the moon, Amavasya, Purnima, and how they form a masa. But I would like to ask you one question. Have you ever really gone out in the night and looked up at the sky and tried to see the moon? Many people think, hey, anytime I want, I can go out in the night, look up, and there the moon will be. Nah, it's not that simple. Because you know that on Amavasya, there is no moon. You cannot see it. Whenever in the night you go, wherever, you cannot see the moon. But what is the reason for that? The reason for that is, I have already mentioned this before, the moon rises with the sun and sets with the sun, so you cannot see it. But if you wait for a couple of days after that, 3 days, or 4th day is my preferred date, and if you look at the western horizon, after the sun has set, you can see a thin crescent moon, a beautiful crescent moon setting. And on the 4th evening, on Chaturthi that is, I will explain that in a later episode, you can see the crescent moon setting for about an hour and a half. It will still be visible up there. But the exact opposite happens on Purnima. When the sun sets, the moon rises, and that's about 15 days after Amavasya. And the day before Purnima is what is referred to by poets as Chaudhumi ka Chand. It's beautiful, because if you go out again in the evening when the sun sets, you look on the eastern horizon, you will see the moon rising. And if you catch it low down on the horizon, it tends to look bigger, and also it'll have an orange glow to it, and that's beautiful. That's a lovely sight to see. So I will request you, in addition to seeing the Stellarium animation, also go out and track the moon for maybe about 15 days to see where is east, where is west, where does the moon rise, where does the moon set, when, how does it look. And if you do all that, you will get a better feel for the Hindu calendar. That brings me to the end of this episode. In the next episode, I will talk and show you the animation of Chandramana Varsha. The definition is very simple. It's 12 Chandramasas make a Chandra Varsha. But there are certain subtleties to it which arise by the astronomical movements of the moon and the sun. I will get into that in greater detail in the next episode. So until then, thank you very much for watching this episode. And if you have any feedback for me, I would love to hear from you. Leave your comments on this video, what you liked, what you did not like, what I should do better, what I should do differently. I would love to hear from you all. And I'm looking forward to seeing you in the next episode. Until then, take care. Thanks for watching and bye-bye.